Okay, in this recording, we're going to be looking at the centripetal acceleration / centripetal force worksheet. And quick reminder, centripetal force, we're talking about things that are moving in a circular path. And so if we talk about this thing, let's say this thing is moving in a clockwise rotation, remember that the velocity is always going to be tangent to the circle. So if I were to let it go, if the object were right here and I let it go, it would be shooting down. If we're over here, it would be over. If we're right here, it would be up. If we're right here, it would be over to the right. So that's the direction of velocity. In order to make that velocity change, what we have to do is we have to have an acceleration. So our acceleration and our force is always going to be center seeking. So we type it as an A sub C for centripetal. And so the centripetal is always towards the center. Okay, there's a whole big mathematical proof on this. Well, not that big, but we kind of ignore it. But remember, centripetal acceleration can be found by taking the speed of the object squared and dividing it by the radius. And then using Newton's second law of motion, we can solve for centripetal force by taking the mass times the centripetal acceleration, or the mass times v squared over r. So if we look at our first one here, it says a runner moving the speed of 8.8 meters per second rounds a bend with a radius of 25 meters. What's the centripetal acceleration? So again, we'll start with guessing. So we know our initial velocity is going to be 8.8 meters per second, and our radius here is going to be 25 meters. So if I want to find centripetal acceleration, it is v squared over r. So we've got the 8.8 meters per second. Don't forget to square it, divided by the radius of 25 meters. And when we do that, we get a grand total of 3.1 meters per second squared. Notice the units, meters per second squared, because we took the meters per second, squared it, giving us meters squared over second squared, and then divided through by meters. So it does give us our units of acceleration of meters per second squared. If we look at the next one, what's the centripetal acceleration on a perimeter of a bicycle wheel of diameter 50 centimeters when the bike is moving at 10 meters per second? So let's guess here. We know the diameter is equal to 50 centimeters. So a couple things wrong here that immediately go, ooh, that's not good. We're talking about centimeters here, so we need to change that back into meters. Remember, the easiest way is to just get rid of the centi and put in the times 10 to the negative second. Again, you can find this on the front page of your reference table. Or you could actually just put it in as 0.5 meters. Okay, but we got to be in meters because we live in an MKS world. The other thing that bothers me here is that I want to make sure, not really sure what that was. Sorry about that. I have things falling all around. The other thing that's bothering me about this is the fact that I want to know the radius. When I'm doing my centripetal acceleration, I need to know radius. And so remember that the radius is always equal to 1/2 of the diameter. We're talking about a circular thing, so a circular path. So we're going to take 1/2 of the diameter, so that's going to make our radius to be 0.25 meters. And the other thing they tell us is that we have a speed of equal to 10 meters per second. So, if I want to find the centripetal acceleration, I have to take my speed squared over my radius. So the speed, which is 10 meters per second, again, don't forget to square it. Divide that by my radius, which was 0.25 meters, and that's going to give us a whopping 400 meters per second squared. We look at the next one here. A race car travels on a circular track of radius 50 meters, so I'm going to write that down. We've got a radius of 50 meters, speed of 40 meters per second. The second car travels on the same track at a speed of 46 meters per second. So now we've got the same track, so we can call this R1 and V1 and R2, which actually just is R since it's the same track. Keep that at 50 meters. And V2, which is at 46 meters per second. How's centripetal acceleration of the second car compared to the first? Well, let's go find out what that centripetal acceleration is. So to find AC of the first one, we're going to take V1 squared and divide it by the radius. So that V1 is going to be 40 meters per second. Don't forget to square it. Divide by a radius of 50 meters. Now, I kind of dropped the unit there, didn't I? Oops. And so that's going to give us 32 meters per second squared. We can then go find, I'll change colors for this. Go find the centripetal acceleration of the second object. Now my speed is going to be 46 meters per second. Don't forget to square it. And divide that by my 50 meters. And so now it gives us a centripetal acceleration of 42.32 meters per second squared. So obviously, the greater the speed, the greater the centripetal acceleration. All right, number 4. To test their stamina, astronauts are subjected to many rigorous physical tests before defined space. Once a festival spinning a device called centrifuge spins power greater than gravity. What speed would an astronaut have to spin in order to experience the acceleration of 3 g's at a radius of 10 meters? So here's what we know. We know we have a radius of 10 meters. And this acceleration, they're saying, is 10 g's. Well, a g, remember, is our acceleration to gravity. So really, all we're going to do, it's kind of just another way of describing the acceleration, is going to be 10 times our acceleration to gravity of 9.81 meters per second squared. And so in reality, our centripetal acceleration is going to be 98.1 meters per second squared. So 10 g's, just multiply our 9.81 by 10. So now I need to go find the speed. So equation-wise, centripetal acceleration is v squared over r. And so our centripetal acceleration was 98.1 meters per second squared. I'm looking for my speed. So that's what I'm hunting for. And my r is 10 meters. And so on a cross multiply, that gives me 981 is equal to v squared. Take the square root, and I find that v is equal to 17.16 meters per second. Number 5, we have a 650 kilogram car, so we know a mass is 615 kilograms, and completes 1 lap in 14.3 seconds. So remember, this is something called the period, the time that it takes to go around once. So this would be 14.3 seconds with a radius of 50 meters. So we know the radius is 50 meters. What is the acceleration of the car? So since it goes around a circle, we're looking for centripetal acceleration. Now, this one we haven't talked about yet. We did in the notes, but we haven't on this sheet. So let's remember that centripetal acceleration is equal to the speed squared over the radius. But notice I am not given a speed here. But this object, and I'll draw this over here, is going around a circular path. One time around a circular path. So if I start here and go go all the way around, this is the distance here is the same thing as the circumference, which in our reference tables, circumference is equal to 2 times pi times r. We were given the time it takes to go around. The time it takes to go around is equal to the period. That's the time it takes to go around once. So I can actually solve for the speed by taking the distance divided by the time, or actually the circumference divided by the period, or 2 pi r over the period. So I need to find the speed first. So let's find the speed. Let's put this right down here. We've got 2 pi times my radius of 50 meters. And we're going to divide that by my period, which was 14.3 seconds. And I need to pause for 1 second while I figure this out, because I did not pre-calculate this one. 1 second, I'll be back. And actually, I'll let you see me do it. So I'm going to go 2 times pi. So I'm just going to go 3.14. And then I'm going to multiply that by the 50 meters. And then divide that by my 14.3 seconds. And so I get a speed of 21.95. So I'm going to round that up to 22. So 22 meters per second. So now I come back over to here into my problem. And so now I know that my speed is 22 meters per second. So now if I take that speed squared, so 22 meters per second, don't forget to square it, and I divide that by my radius of 50 meters, I'm going to get a centripetal acceleration of 9.65 meters per second squared. Now, it then wants me to find what force. Well, this force is going to have to be centripetal force. So I'm going to put this in a nice red here. My centripetal force, remember, is just equal to my mass times centripetal acceleration. So we know the mass, that's 615 kilograms, and we multiply by the centripetal acceleration of 9.65 meters per second squared. And so I'm able to find it to be 5,936.5 newtons. Now again, if you use the 22 like I did here, instead of using the actual 21.95, whatever it was, you're going to get a slightly different answer. That's okay, we're close enough. All right, so a couple more on here. Number 6, Missy's favorite ride at Top Seal Fair is a rotor, which has a radius of 4 meters. So we have a radius, 4 meters. And we have a period of 2 seconds. So we got another period one. To make one full revolution. Okay, so that's going to be the period. We want to know, what's Missy's speed in the rotor? Well, we just covered this. We said, hey, in order to find the speed, that's equal to the distance divided by the time. The distance is actually the circumference, and the time is the period. Now, circumference is equal to 2 pi times my radius, and we'll divide that by the period. So let's plug this in, because we know the radius, we know the period. So we've got 2 pi times my radius of 4 meters, and I'm going to divide that by my period of 2 seconds. And so when I do that, I'm going to get 9.65. Oops, sorry, my fault. I need to go back and redo this one second because I didn't find the speed. You know what, let's bring up that calculator again. Where's that calculator? All right, so we've got 2, so let's clear this. 2 times pi, which is 3.14, and we multiply that by 4, and divide that by 2, and we get a speed. Well, that seems a little bit off. Let's try that again. 2 times 3.14 times 4 divided by 2 gives me 12.56. That sounds better. So 12.56 meters per second is my speed. Then they wanted us to find the acceleration. Well, centripetal acceleration is v squared over r. So we take that 12.56 meters per second. Don't forget to square it. And then we'll divide that by my radius, which we know was 4 meters. And so when we do that, we end up with 39.5 meters per second squared. All right, number 7, Roxanne is making a strawberry milkshake in her blender. A tiny 0.005 kilogram strawberry, so pretty darn tiny. So when you have a mass of 5 times 10 to the negative third kilograms. Now you can leave it as 0.005, that's perfectly fine. And it's contained with a speed of 14. So we know the speed is 14 meters per second. Held on by a centripetal force of 10 newtons. So we know the centripetal force is 10 newtons. What's the radius? So we're looking for the radius here. So for this, I'm going to use my centripetal force formula. And you're thinking, oh, m times a sub c. Let me change that. You're like, well, wait, how does that help us? It doesn't give it the radius. Remember, we can also write mass times the speed squared over the radius. This v squared over r, that's the same thing as a sub c. So now I can just plug in. I can say, all right, well, I know my centripetal force is 10 newtons. I know that my mass is that 5 times 10 to the negative third kilograms. I know the speed is 14 meters per second. And I'm looking for the radius here. So I'm going to take 5 times 10 to the negative third times 14. Don't forget to square it. And then divide that by the 10. And I'm going to find that my radius is 0.098 meters, or 9.8 centimeters. And our last one, we've got a mass of 1.5 kilograms. A 1.5 kilogram rock is tied to a string that is 40 centimeters long. So my radius is 40 centimeters. Now the reason for that is the radius is because if you have a string and you start swinging it around, and I'll show you this with my keys when we get into class if you have questions on it still, but those keys are on the length of a string and they're going to go around. That'll be the radius of that circular motion. But another thing bothers me here, it's in centimeters. I need to change that into meters. So I'm going to go 4 times 10 to the negative second meters. Now, it does tell me it'll break when the tension exceeds 250 newtons. So the maximum force, the tension or centripetal force, is going to be 250 newtons. And so we're looking for the greatest speed. So for this, centripetal force is once again mass times centripetal acceleration, or for the one we need, mass times v squared over r. And so we know our centripetal force is 250 newtons. We know our mass is that 1.5 kilograms. We're looking for the speed in this case, so we're going to just have to solve for v. And our radius is 4 times 10 to the negative second meters, so only 40 centimeters. So now when I cross multiply this, I'm going to 250. You know what, for kicks and giggles, let's draw this one out. So cross multiply, you get 250 times 4 times 10 to the negative second. And that's going to be equal to 1.5 times v squared. So I'm going to get 250 times 4 times 10 to the negative second, and then divide that by 1.5. But then I have to take the square root. And when I do that, I find that my velocity, my maximum speed that I'm going to be able to have, is going to be 8.16 meters per second. So I hope this helps in this particular worksheet, and I hope you have a great night. See you later. Bye.